So in our next section, we're going to look at using fabric extenders or FEXs in conjunction with the ACI and the Nexus 9000s. So up to this point, we've already previously talked about the FEXs associating to the Nexus 5Ks, the 7Ks, and also the UCS fabric interconnects. And we saw the generic order of operations in regular standalone NXOS mode, where we need to enable the FEX feature. We go to the physical port level, connecting the parent switch down to the child FEX. We set the interface mode to FEX Fabric, which means that behind the scenes it's running the VN tag frame format, the 802.1BR for a Bridgeport extension. We specify what the module number is, essentially the FEX associate number. Then we wait for the FEX to initialize, to acknowledge, and then we have access to the physical interfaces, the host-facing interfaces that are going down to our access layer, like our access servers. Now we'll see in the case of the ACI, the general logic is the same in terms of associating the leaf switch to the fabric extender and then configuring the policies that are going from the fabric extender down to the end host. But as usual with the ACI configuration, the big takeaway from this section is going to be how do the objects fit together. So we'll look at this in two different manners. How do we configure the fabric extenders through the wizard, through the Quick Start wizard, which is going to be for configuring interface, port channel, virtual port channel. And then we'll also look at the manual object structure. How do we connect everything manually together? Ultimately, the end result is going to be the same, whether we're using the Quick Start wizard or manual configuration. Really, the only difference is going to be what is the naming convention that we use for the objects. But functionally, we'll see that the two solutions are going to be equivalent. So before we get into the configuration, let's talk a little bit about some of the design, not necessarily limitations, but the design caveats that go along with the ACI and the fabric extenders. And first and foremost, when we're talking about layer one physical design, one of the key points to note here is that the Nexus 9300s, which are going to be the leaf switches, do not support connecting the fabric extenders on their uplink interfaces, okay, which are called the ALE ports, the application leaf engine. Essentially, those are the interfaces that are running the VXLAN tunnel and the routing behind the scenes, the infrastructure VRF or the infrastructure tenant that's routing ISIS from the leafs to the spines in order to build the shortest path tree for the underlying VXLAN fabric. So the key point about this is that if we have like a 9372, which we have in our particular case here, it has 10 gig downlinks to the access layer and 40 gig uplinks that go to the spines. One of the limitations that you run into here is that if we have a fabric extender that is using 40 gig uplinks as opposed to 10 gig uplinks, the problem you run into is that you can't take those 40 gig ports of the extender and plug them into the 40 gig uplinks of the leaf switch. What instead you would have to do is use a 4 by 10 gig breakout cable and then use 4 of the access facing interfaces, essentially the host facing interfaces of the leaf to connect to the fabric extender, as opposed to using the uplink interfaces. So just be aware that from a physical build of materials point of view, just because the leaf has the 40 gig uplinks doesn't necessarily mean that you can use those to attach the fabric extenders. And going forward, there may be some changes in the platform limitations, but as it stands now, with the 9372, and then pretty much most of the other common modules that we'd be using as the leafs. Like if we go to the cisco.com/go/nexus, and then let's go down to products, Nexus 9K, and then our 9300 EXs, which would typically be I want to say the 48 port 11025, which is 93180 YCEX. So this model as well, which is the 10 gig and 25 gig access layer switch. There's 40 gig and 100 gig uplinks on the ALE ports that would normally go from the leaf to the spine. And just be aware that you cannot connect the fabric extenders to those particular ports. Okay, so you essentially need a specific cable that is going to be Cisco 40 gig to 10 gig breakout, which is basically going to look like this. Okay, so it's a QSFP on one side, a 40 gig port, and then it is essentially 4 regular SFPs on the other side. So from the FEX's point of view, it's only going to be taking up 1 physical uplink, but from the leaf switch point of view, it's going to be taking 4 downlinks. So you do have to, like I mentioned, take that into account for your physical bill of materials when you're planning out the layer 1 wiring. Now the 40 gig access switches, that's not going to be an issue. So if you have a 40 gig host-facing interface port, then you can go from the leaf switch down to the fabric extender. Okay, additionally, one thing I don't have listed on the slides here, but it's kind of assumed based on the rest of the design, is that the fabric extenders cannot attach to the spines. The fabric extenders can only attach to the leaves. And then like I mentioned here, on the leaves, they cannot connect to the ALE ports. They need to go on the regular host-facing interfaces. Okay, the other caveat here is that the ACI only currently supports straight-through fabric extender designs. So no enhanced VPC or no dual-horned FEXs. So from a physical wiring point of view, we're going to have parent switch 1 that is physically going to connect down to fabric extender 1, parent switch 2, which is going to connect down to fabric extender 2, and then the FEXs then can dual home to the end host. Like we talked about in the standalone NXOS mode, essentially this is a host VPC. So between the 9K leafs, we're going to configure a VPC domain. Then from the leafs up to the spines, we're going to have the pure keep alive, the pure link, essentially synchronizing the control plane between them. And then the data plane is going to be the links from the fabric extenders down to the host interfaces. But as we know from a config point of view, before we get to that point, we need to associate the fabric extender with the parent switch. Okay, so like I mentioned, there's going to be 2 different ways that we can do this, either from the quick start config wizard, or we can do it from the manual object definition.